Now, we will proceed with the second dialogue session of today, entitled Application of Artificial Intelligence in Biometrics Forensics. For that, we would like to invite Mr. Nazri Ahmad Zamani, specialist from Digital Forensics Department of CyberSecurity Malaysia, as moderator for this dialogue session. It is our great pleasure to invite on stage Professor Dr. Raveendran Paramesran from University of Malaya, Associate Professor Dr. Siti Norul Huda from the National University of Malaysia, and Dr. Yong Haur, Director of Recorgine Technology, to discuss further on this topic.
Assalamualaikum and a very good morning. Okay, my name is Nazri Ahmad Zamani and I am the specialist in Digital Forensics Department of CyberSecurity Malaysia. Okay, first of all, let me welcome you, esteemed ladies and gentlemen, to this session. In this session, we will be discussing about one of the most hot topics, the most challenging part in digital forensic, which is the biometrics. Biometrics in forensic, as we all know, is our reliance on machines, okay, instead of a human, in order to identify or verify the identity of a person found inside a digital evidence. Whether it be face, iris, speech, gait, body contour, we have let the machines to do the critical task of linking a person to the unknown identity inside a photo, a video, or audio for us. As we have almost zero tolerance towards human shortcomings in their ability to make a good judgment when it comes to justice, we struggle on to build better machines in our state. And over the decades, the machines have evolved to a level reputable enough to rival human in making a very precise matching. The emergence of new AI, as we all have heard, the machine learning, the deep learning, the VGG, the ResNet, the GoogleNet, YOLO, GANs, have awed us with their prowess. But the technology is a double-edged sword. They also come with their own fallibility and also threats. So in this session, we will discuss the future of AI in biometrics forensics. So without further ado, let me introduce you, okay, to the panelists. First of all is Professor Raveendran Paramesran. He is a professor in the Department of Electrical Engineering in University Malaya. He has 31 years experience in the research of machine learning, AI, and the application. His experience is monumental contribution to our country. He already retired in May 2018 and currently appointed as an honorary Prof since then. Second, Prof. Madya Siti Norul Huda Sheikh Abdullah, who is actually currently the leader, okay, the leading in the Digital Forensics Department under Faculty Technology Science Maklumat in UKM. Prof. Huda was our long-time collaborator in research in digital forensic and also an associate in our Master in Cybersecurity program in UKM. And last but not least, Dr. Yong was a former associate professor in Utah and now is currently the director of Recorgine Technology, a computer vision and IT company for transportation industry that he founded 13 years ago. He also served as an adjunct professor in Utah and the advisor for Agritix, an AI company for agriculture and also forestry. So I welcome to the panelists today. Okay, without further ado, let me invite Prof. Raveendran. So I know Prof. Raveendran from his research in gait recognition technology. So I would like to know about how ready the technology is for the future application, in the biometrics in forensics, and can deep learning can be seen as a potential solution for gait recognition.
Yeah, thank you, Nazri. Is it on? Oh, sorry. Thank you, Nazri, for your introduction. What I will do is I do a short presentation of the slides. Sorry. Yeah, better. Okay. So when it comes to biometric, there are different ways of analyzing people. One is facial recognition, iris, fingerprints, and the other one is gait. So my talk would be centered on gait technology. How far it has gone, how the strength of the technology, and in what areas you apply this technology. Okay, so biometric gait recognition refers to what? Verifying and identifying person using the walking style. But physical biometric traits include, among others, fingerprint, facial features, and iris. So behavioral biometrics such as gait recognition are intended to capture the unique signatures delivered by clients. More than 24. So if you look at an image biometric, you have to take features. So the number of features you take is important. So typically they can take as far as 24 unique factors to affect human gait. And another one is it requires users to exert minimum effort. And then lastly, you can employ them in many different types of situations: airport, entry checkpoints, and entry to buildings or to home-based security system. Okay, and then you have to divide this biometric gait recognition group to 3 categories. One is machine vision, the other one is floor sensor, and wearable sensor. I'll go through this quite a bit. Okay, and the photo, what they normally do is, step 1 is to capture a biometric sample of the person. Step 2 is to extract relevant features from the capture. And 3 is to compare the extracted feature set against the template set in the database. And what does it do? It has two things it does. One is the verification and the other one is identification. In the verification mode, what does it do? The system performs a one-to-one comparison, and the system decision is either to accept or reject a claim identity. In the identification mode, the system performs one-to-many. It's just trying to match up with any one of the possibilities. And the system aim is to assign identity to one of the user templates. Okay, and then when you do all this, you will have success and failures. So they categorize this into 2 types. One is false accept rate and false reject rate. And what is the false accept rate? Is wrongfully accepting an imposter user, false negative. The other one is the wrongfully rejecting a genuine user, is a false positive. So system decision is based on, how do you make this decision? It's based on a threshold. By changing the threshold, the success rates also varies. Okay, this is machine vision based gate. So gate is captured using a video camera from a distance. You mount the camera, is captured, and video image processing techniques are employed to extract gate features. And then most of the gate, machine vision based gate recognition algorithms are based on Charlotte. So here's an example. You capture some image, and then what you do some pre-processing, you eliminate, and finally you end up the Charlotte, and that is the black and white. And then from there, you try to measure the distance, the leg movement, the timing, everything it can be measured from this. Okay, what's the advantages of using it? Okay, compared to other methods, it'll be captured from a distance. You can capture it from a distance. And then the other thing is they are usually used in civilians and forensics. Robbery. Okay, but when you think of robbery, somebody comes into a bank or what to rob. They normally wear the face mask, and they have gloves on. So you don't have any kind of identity. You can't get any characteristics out of it. So the only thing left here is their gait, the way they move around and all that. So this is one area where the gait application is very important. And then the next one is also quite becoming important is what you call floor-based sensors. So what you do is you put sensors now on the floor. So as you walk, it captures your pressure, your timing and all that. So this one is like, it uses the ground reaction force induced by a client's footsteps on a floor sensor to construct biometric systems for client identification. So this is gaining quite a bit of becoming a bit popular now. So it involves what? Spatial and temporal features. And this is an example of a sensor mat. And then this is you have the images on the top are what you call the raw. When you step, it captures if you look at the color, indicates different pixel values or the sensor values. Okay, and then from the top you go to the bottom one, you will see it is reconstructed, processed, so you get the footprint, and then you can see the colors. You can see the colors. They indicate the pressure and all that. So what you have two users. On the left, the first user; on the right, the second user. But if you look at it, can we really identify? It's not easy. So this is where the AI technology comes to play. To capture these images, capture this, and to read it. So you use deep learning methods to learn these figures, data points. So that's because you can go do all kind of calculations and all that, but it's very difficult to get the accuracy that you want. So this is an application of why artificial intelligence is becoming popular. And then, the footstep feature gave the footstep recognition research. So here now they have feature engineering involves a careful selection and design of complex, time-consuming, handcrafted features. So they use spectral, wavelet, holistic, all of that to get about 24 features.
24 features.
So the advantages, typically can be deployed in access control application, usually installed in front doors of buildings. Can be deployed as a standalone or multi-modal, that means together with facial recognition and things like that. So in addition to providing identity, they can also indicate location information within a building. Okay, gate is collected. This is a wearable sensor. So you wear sensors in the body and you use the motion recording, more of acceleration. Okay. And this is where you put these wearable sensors. This is normally, in Japan, it's quite, for old age and all that, they wear a lot of wearable sensors so that they can detect anything wrong or their movements or anything, because most of them stay alone, you see. So they need information if anything has gone wrong with them. So they're quite popular in Japan. So advantages, you can collect data, it's not obstructed. Proposed for protection, user and mobile advances, because now it's becoming smaller and smaller, and so it becomes easier to use. So what are the challenges? So there are, of course, in anything you'll have challenges, and let me group them together. So there are external factors and internal factors. What do you mean by external factors? The viewing angle, frontal, lighting conditions, because like now we have ACE, surely you'll be affected if you have these videos outside and all that. Then the other thing is the walking surface conditions, because you are looking at if your surface is not smooth, then your movement also will change. You'll all be dictated. If there are a lot of glasses, stone, you try to avoid. That will cause, the other thing, of course, the type of shoes you wear, sandals, then of course you very backpack, object carrying and all. Also all these are factors. So the internal factors are, of course, when you are injured or you're sick, everything changes also. So that is the problem with the internal. Of course, if you are pregnant and of course if you are losing weight and all, again your gait will also changes. Okay, and then, so then what happened is you don't try to just use gate alone, you try to combine with other modalities like fingerprint or, facial and all that. Will the performance improve? Will you get a high, people always want to get higher and higher performance. So just using a single modality as opposed with combining, and how would you combine them and what methods? So again, they do a lot of research in these areas to show that they can be combined and they get better performance. Of course, then the most important thing is actually the security. This one thing about gate thing, they have not done much research on the cyber attacks and things like that. Most of the research is spent on perfecting the art or getting a higher success rate. So security, they are just looking into it and just started. So some research has begun, and what they do is they look at two types of imposters, passive and active. So what do you mean by passive? Passive is the attacker walks as himself, he doesn't change anything, and hope that will be matched in one of the samples in the database. And in the active imposter, the attacker tries the following: modifies walking style, hoping to better match the targeted person gait, and the other one is you have some knowledge of the system and then you try to hack the thing. Okay, and this is what I meant. Okay, so these are the references. You can go, if you want the slides, I can give it to you, anybody here. So thank you very much.
Thank you, Prof. Raveendran. So actually that there is one professor in United Kingdom actually that I used to talk to. So he's actually successfully using the gate technology in order to make a hooligan confess actually. So what he did is that he took the subway. At the crime scene, so he actually put his mask on. So he beat up some people. So actually that CCTV recorded actually cannot actually figure out, cannot get. So he actually denied his involvement in the in the fights. But by using the gate technology, so they actually managed to establish his walking in the crime scene and also in other subway station in which before he wear on his mask. So that hooligan.
So that's all captured.
But can I ask one question, Prof? So how can we enroll? In the process of enrollment,
So what you need to do is you have to have a database of the people. Then only you can do a matchup. If you don't have a database of people, then you cannot do a matchup. So the first step is to have a database. So you have to collect samples and input, and this has not been done in our in the law or what, in the crime scene or what. But in other parts of the world, they have done it. So you need to have database. Then if you suspect someone, and then from the gate analysis, you extract the feature, and then you see whether it matches up with any one of them in the system. So that's where what first step is like an enrollment, like IC identity card, like that. We have to give our own data, walking samples.
Do they have to walking freely?
Yeah, freely, and then in situations, in different conditions, you have to put them so that you give the intelligence to the system. You can't have a fantastic surface and all that. You have to put them in various conditions. And so the robustness is given, and that's how you build the intelligence in the system.
I think it will be easier for data collection for population, but for the suspect, it will be maybe quite challenging.
Yeah.
So actually, we cannot make this, the suspect, in the tahanan remand, to walk freely, just like that. We hope. Okay. I would like to thank you, Prof. Raveendran, for the first round of the question. Moving on, so I would like to invite Associate Professor Dr. Siti Norul Huda from FTSM UKM. Okay, so actually Prof, you are actually currently championing the curriculum of the digital forensic in UKM, and you also have been very active in researching AI in the application of digital forensic. So what do you think of our readiness when it comes to the implementation of AI, the deep learning, machine learning in biometric application, especially for the forensic?
All right, thank you, Mr. Nazri. I just want to share to everybody that actually three of us are sharing with the same supervisors. Actually, it's Prof. Mazuki Khalid. Actually, we shared the same supervisor together with the Dr. I'm so happy to meet them on the stage together, and as well as Dr. Ravi. So thank you for the invitation. It's unfair to say that it's only UKM that offers the cyber forensics. I guess the other universities, such as UTM, yeah, I think APU, and think UPNM, MSU, USIM, and URA. I think they have done a lot of talent creation as well in the area of the cyber forensics. But in the sense of biometrics, I think in the forensic side, we have involved almost 10 years, but our digital forensic programs have started around 6 to 7 years already. And apart from them, we have a group of research groups who's handling on biometric research, around 6 to 7 researchers. And I think we have also quite a number of many of researcher students from undergraduates as well as from postgraduates, and those actually these students actually are part of our assets who are actually bring our brain into reality. So I might say that the lecturers, we always like to envision things, right? To think more than the other futuristic thing that other people can do. So do our research center, we call it a Center for Cybersecurity. We have a digital forensic lab where we actually create devices that will support technology, or we call it as AI tech fashion, that can support for security aspects in maybe in fintech. We can also for access entrance or for the smart city applications and so on. But in order to make our students always up to date or cutting edge, so we will always, of course, do the most recent research trend. Not only what happened in Malaysia, but also international wise. So, and we have to use or we have to translate all the research that conducted in our lab into the class. Yeah? So I think I'm so happy that cybersecurity invite us to build up a co-curriculum. And one of the I think we have 3 subjects. We have digital forensic fundamentals, and we have data recovery analysis. This one I think we learn also about reverse engineering, and the other one is the digital media forensic analysis. So I think I co-teaching with Mr. Nazri. So we always try to improve our teaching by using the technology that has been improvised by our students, and we translate them into the class. Okay, we translate them into the class so that the master students, even they are conducting a course, probably a 5 days face-to-face of a meeting with the lecturers, but they're able to grab the information fast about the cutting-edge technology, especially about AI tech. And deep learning is one of the current trend methods, and is not only able to auto-crafted the features learning. If we compare with the traditional way, where we use it the handcrafted way to find the features, but with the power of deep learning tools, we actually can pick up all those information features and let the machine learns which are the the best features that to be represented for each of the applications that we're going to develop. So I think most of us are using face recognition, etc. But they're also afraid of scam, or in other words is spoofing identity and etc. So our students also needs to be very creative how to detect anti-spoofing, multimedia spoofing. So we also teach them how to create anti-spoofing liveness detection before they try to recognize the identity. This is to give a broad idea of the students how people are crazy enough to think how to make people fool in any kind of security system. And we'll see that biometrics, actually the students, in fact my students, some of them are creating their own business. Yeah, after they complete their studies, they create their own business, and like I think Dr. Tay inherit of Prof. Mazaki Khalid's entrepreneur identity, yeah, and create his own business company, and it goes the same to my students. Yeah, they also develop companies of their own to improve their biometrics systems that they have been developed previously. And I think this is a good indicator saying that that our students or our graduates, yeah, are becoming very we call it aggressive, try to embark in the world of data scientists. People say that data scientists are the most sexiest job. I'm not so sure whether is that true or not, but the sexiest job means that it's going to be very hard, very popular in terms of money making upon their inventions. So I think the other companies as well, the big companies that we have, apart from company of Dr. Tay, is the Aerodyne, ELM, Audit, Security Asia. Most of them are using deep learning open source libraries, and sometimes they are using a pre-trained model. But if the company is actually conducting a little bit of research, I guess a pre-trained model is not sufficient enough, yeah, to accommodate with the everlasting challenges now. So what you need to, of course, you need to identify how to improve the machine of the deep learning himself, such as taking part into the dropouts or the objective functions, or to the drop loss, to the loss functions, and or to the localization functions. So those are the things that actually can improve or give a better dignity to the most Malaysia AI companies, so that they can invest or create more innovations that are able to create a better model. And it is true that that AI sector, will be double the rate of innovation by the year of 2021. So if I try to search in the Google about Malaysian companies, we have about more than 20 companies already involved in this AI technology, fashion tools. But I guess when the government says that it will be double rate in the 2021, that shows that the government as well as the industry will invest a lot of money to create more applications that use deep learning. So with that, I think that's all.
So, Prof. Huda, so when it comes, I'm interested about when you said about all these emerging, all these startups, emerging right now, and also the open sources that we use. So I would like to know, is there many innovations done on the, when it comes to the biometric forensics?
Yeah, I think CSMs are doing now. Yeah, I mean,
One of it, yes,
yeah,
we are
it's a
doing
3D facial forensic.
Mm-hmm.
And as well as I think UTM is also Cairo. I think Cairo UTM is also doing on the biometrics as well. I think Dr. T is involved here before. We have also do some little bit of biometric as well. Also guide recognition, where the PDRM is actually ask us to, okay, can you please get and catch this man? We could not find his face very carefully, but we only get the posture of the suspects. So the demand is there. Actually, by the law enforcement are looking for solutions for them to create a better we call it how to improve the law enforcement in our country, and by involvement many companies in the biometric sectors, I think they will help. They will be able to assist more cases, which will if I can say to you some statistics that had been discussed during the February 2017. PDM reported in 2017 saying that there are about 13,000 cases of cybercrime cases in Malaysia. However, in terms of the cases that able to be brought to the court is only 40 cases. So you can just imagine the needs of the talents, that we need to create more talents in order to give inferior information to the community, so that they will afraid to do unethical things. Okay, so if you have 13,000 and only 40 gone to the court, what do you think the other the balance of it? And this is a true story. The crime rates are increasing very fast. Sometimes it can go to exponential. If we do not prepare a better personnel that are able to, especially reverse engineering in deep learning, especially in deep learning approach, because nowadays we see the crimes are using AI to do all the attackings, etc. So of course, we also should create weapons by using AI as well, but of course it will be more powerful than that. Then of course we can compete them. So I would suggest, I think most of us are lecturers and educators, so it's good that if we involve the students with biometric research, at least they have the fundamental understanding on it, in order for them to help to do some forensic analysis later, to catch on the, you see, the balance of 12,000 criminals who are on. He's just running on the road now. Okay. Okay. All right.
So I would like to add something. So for us in CyberSecurity Malaysia, when it comes to the biometrics, it's always emphasized on the face recognition. So what the challenges that we see actually is basically the face recognition is image classification in deep learning. So when it comes to deep learning, you may have the result, for example, 90%. Is it positive or is it negative? If it's positive, why is positive? If it's negative, why? So that's the question. But, but the thing is, whether it's positive or negative when it comes to the results, but, how confident you are, when it comes to your result. So when it comes to, if you see the data science, the scenario nowadays, they talk about a lot about, maybe that about the K-fold, stratified K-fold methods, in order on how to evaluate your results, apart from the you know, the, what we call it, the precision, recalls, and everything and whatnot. Also, you know, and nowadays we have the assemble methods, you know, so we can have like many kinds of classifier that you can test, you know, in the data sets of face, and also put on the, you know, the suspect face, you know, and how you're going to evaluate the results, you know. The assemble method is one of it, but of course we don't have that much of an opportunity, you know, to explore them all. So I would like, you know, to invite you guys, you know, maybe come to us, you know, and talk about, you know, this kind of research, because it has, you know, a lot of issues that we need to discuss when it comes to the biometric in forensics. So when it comes to image classification, so Dr. Yong here is actually is a person that I know, you know, he is my teacher when it comes to image classification. Okay, so he has a huge experience in applying AI, okay, at both in research and also in application building. So, Dr. Te, okay, given the current demographic of AI globally, so what can you say about the impact of this new generation of AI? For example, the deep learning, and so what is the implication of image classifications, especially in the biometrics?
Perhaps I have prepared some presentations. Maybe you can click. Can I have it? Okay. Although I'm in the industry, by and large, I'm still an academic. I used to juggle between academics and business. Yeah, still okay. Recorgine Technology is actually the company that specializing in computer vision in two industries. One is actually in the transportation, traffic, and then the other one is security. Okay, it was actually 13. So we gone through the exercise from the pre-deep learning era that we developed using feature extraction until lately. We embrace a lot of deep learning for our license plate recognition system, for our this vehicle classification algorithm. So with and without deep learning, I see a lot of difference, okay, in terms of the maturity of the system as well as the human resources required, okay. Okay, I don't want to go into details. I just show you some of the result lately. You know, for the past 10 years, why deep learning suddenly pops into everyone's mind when they consider this cool technology. You can see this. This is actually the large-scale visual recognition challenge, or some they call it a ImageNet. They have a huge data set which has about 10,000 different type of images, huge different classes. Okay, 10,000 classes. So in the early stage, in 2010, but that was actually 9 years ago, using the classical this feature extraction plus machine learning algorithm, right? The error rate is about 28%. The next year became 26%. People are changing the feature extractor and then improve over time. Now in 2012, that is actually the first time that deep learning algorithm or end-to-end learning, meaning that there is no feature extraction. It's a huge neural network. We eliminate the feature extraction and let the neural network learn the feature by itself. And that is actually the time you see a drastic drops in the error rate. And ever since that, more and more teams is using deep learning to help solve this, to run this competition. And from 16 to 12 to 7 subsequently. Based on the result, human recognition is about 5% error rate. Okay? And after 2015, that is actually a time that machine beats human in this competition. And now it's about less than 3%. So you can see that with huge number of data, with the same algorithm, but bigger level, and we can achieve very fantastic result. Now, just to give you the idea of how the image looks like. So for the okay, this is actually an image, and the label. This is actually a true label. This is a mic. Okay, so that is actually the result of the machine. This machine mic. For example, this is actually a container ship. You can see from the computer vision perspective, it's actually very challenging. You can see a lot of wave here and things like that. Okay, and for example here, the label is actually cherry because in front there are cherries here. Okay, so the machine basically gave a wrong prediction. It's Dalmatian. Dalmatian is actually this dog, right? So, but then the second best is actually grape and elderberry. You can see, although the result is wrong, but it makes sense. It actually make a lot of sense on the result. Okay, for example, the mushroom. Although the label is mushroom, but this machine, the deep learning algorithm tell this is agaric, and agaric is actually another type of mushroom, a specific type of mushroom. Okay, so it make a lot of sense in this. And also 2 years ago, AlphaGo is a Google company. Basically, you developed for several years of this Go playing machine called AlphaGo. And in two years ago, he managed to beat the world #1. Okay, and they are using many different type of deep learning algorithm, mainly the convolutional neural network, which is actually looking at this particular patterns, and then try to see, okay, given this distribution of the white chess piece and black chess piece, what is actually the best place that I should put my chess piece? Okay, and you see a lot of these chess pieces, and basically you look at, because one of the reasons why they use this is in Go playing, they have a lot of record of this chess. Human play among themselves, and then you have a lot of records. So they use this as a training data for the machine. So the machine learn from here. And after that, basically, machine play with another machine, and then learn from each other. Okay, in 2017, basically, this machine is able to beat the best human player, which is Kerjie. And after that, they retired this AlphaGo, and they redo the AlphaGo. They call it AlphaGo 0. And AlphaGo 0 basically is a machine, a chess playing machine that doesn't learn from human, but they call it a reinforcement learning, and then they learn from each other. Machine playing with machine, and then play. So within less than a day, the machine basically can beat these human winning AlphaGo 100 to 0, which is much better. Now this AlphaGo 0 is actually labeled as 10-9, which is the highest level of Go playing master. Okay, now we also use it for image segmentation. So you can see in the next thing that you see is actually human autonomous vehicle. In autonomous vehicle, we need the machine to be able to see from the seat, right? Okay, so all this thing used to be human labeling. You have to label it. Okay, now this is actually a car. This is a tree, and these are roads and things like that. But again, today basically you can let the machine to label it by itself. Another one, more interesting one. This is just a 5 years old technology. from the beginning. It was started in 2015. How do I? Sorry. No. No, I think I want to play the. No. Can I play the video? No. No. The previous one. There's a video. No. Yeah, can you go to the picture and then, yeah, yes. This is called generative adversarial network. Again, it's actually two neural network fighting with each other. Okay, one neural network that is actually do like what we normally assume that we can do. Given the picture, tell you that who is this? This is your mom face. This is your dad face. Okay, but there is another neural network called generator that is do the inverse. Given your mom face, generate the image of your mom face. Given the signal of a face of your dad, generating your dad's face. And let these two guys play with each other. So one guy is to generate face, the other guy is to make sure that this image is actually a generated face, not my dad face, although it's actually. So then these two neural network basically play with each other over the time. Then the generator become better and better in generating faces. Now these are all artificial faces. You can see that these are all artificial faces, not the real faces. But you can see that it is actually looks very similar to the real face. Okay, and you can. This is actually from the low resolution to high resolution. Okay, so you can see some small defects, but this is just 5 years of research, and you can see a lot of interesting development. You can see within another 2 to 3 years. Okay, I don't want to go into detail. You can find it over the okay, now this looks interesting. You can the latest space. You can see I want a face with a wearing spec, a face wearing spec. I want a face with a female face, long hair female face, and so on and so forth. So you can decide that, rather than just random faces. Okay, so what I'm trying to say here is actually deep learning, although it's actually a buzzword today, now that is actually because of the three key success factors. One is actually the algorithm, which the algorithm is actually incremental improvement, not big improvement. The algorithm that we use today was actually used 15 years ago or 20 years ago. Like for example, convolutional network. What makes it different is actually, first is actually the data. Now today we have a lot of data, a huge number of data. And second thing is actually with the data, we have a huge computation power, right? With the NVIDIA GPU, and now with Intel Movidius chipset, and Google Coral, and cloud computing TPU, tensor processing unit of Google. So it now makes the things very easy to train. We used to, for example, without the GPU, a simple task that may take 14 weeks, 2 weeks, 14 days to do, but using GPU, it just takes about 7 hours. Now that kind of improvement. So it makes a lot of things interesting. Okay, so from the company perspective, now neural network used to be very academic, only the people in the researcher try to use it. But today, basically more and more companies can embrace it because why? This is actually a very promising engineering solution. Most important thing is actually, for example, now there are a lot of models available. You can have a very quick, rapid prototyping. It's not perfect, but you can see, you can develop something that is actually MVP, minimum viable product, for you to quickly come up with a prototype. And using the weight that previously other people had trained, and they make it open. Honestly speaking, machine learning is actually one of the most open research community currently, compared to others, other research community. That's why the weight is actually available, the algorithm is available, you can download in GitHub, and then you can start playing with that. With the weight available, you can do the transfer learning, you can use it to transfer, to learn, to optimize further on the problem that you have on hand. Now, the second point basically is actually end-to-end learning, which is actually very important. For example, for face recognition, right? You don't, previously, you need to have features for faces. You have to extract features for faces in order to do face recognition. And then if you want to move from, if you already have face recognition, you want to move to, for example, identifying gait, right? Then you have to throw away everything of anything about face, and then you have to think about how to extract features of gait. Whereas using deep learning basically is end-to-end, meaning that you just give a lot of data of gait or face, and basically they will learn by themselves. And using the LSTM and GRNN, this type of temporal sequence neural network, you can handle temporal sequence very, very easily. Okay, I think I take up too much time. To answer to Nazri question, I think now deep learning basically is actually a double-edged sword, as what Nazri mentioned. Is about how we use it. If this tool is on the hand of the bad guy, so they are going to do a lot of bad things. So there are a lot of possibility of this. For example, you can generate model to fraud the system, right? So before these tools is actually passed to the bad guy, we better let's embrace the technology. Let us, all of us, basically use this technology extensively because this technology, if you can use it very nicely, for example, in biometric forensic, you can combine multiple information sources together easily. Right? For example, fingerprint. Instead of minutia, you can combine minutia plus the vein at the, either it's actually a front layer or in the back end layer, which is actually the output of the neural network you can combine together. Or you can combine spatial and temporal information. For example, iris recognition plus the eye blinking, so that you make sure that this is actually a live eye that you are looking at. And so on and so forth. And generative model basically help you to generate a lot of close to real life kind of data, so that you don't really need to have so much data collect from the real world. You can generate even more data. Now that is actually my small little opinion about this deep learning in this particular area.
Okay, thank you, Dr. Tay. So actually that almost we are running out of time. So I would like to open the Q&A session, okay, to the floor. If you have any question. Okay, while you are figuring out your question, so actually that I would like to address this issue, okay, the malicious AI, okay, because all the the scientists of AI, the deep learning, okay, around the world, they are addressing this issue, the malicious of AI. So as you can see, what Dr. Tay actually presented, okay, the use of the guns, okay, in generating fake information, and this fake information, as you can see, are highly realistic. Don't you agree? Right? So. And also, one of the the viral issue in our country is the issue of deepfakes. Okay, so where nowadays they can successfully putting on Steve Buscemi face onto the Jennifer Lawrence face on the global, you know, Golden Globe Award videos. Okay, it's very, very, you know, very, very impressive. Okay, so this is actually one of the issues. And let me tell you, to detect these kinds of fake is actually cannot be done, no longer can be done with the conventional forensic method. So it requires, you know, for us to do the research again in order on how we can detect these kinds of attacks. So is there any question among the floor? Would like to know? Yes, Encik Zabri.
Zamani, the head of Digital Forensic Department, CyberSecurity Malaysia. I would like to ask the opinion of our expert here, okay, regarding the trend in China. In China, where facial recognition is so good in terms of providing or ensuring public safety. Yeah, so that you can trace. There is one video by, I don't remember, but the journalist can be traced within less than 2 minutes. Yeah, and suddenly and not long after that, in San Francisco, the U.S., there is a movement which you know, fighting for the data collection of facial recognition, whereby they forbidden the facial recognition in San Francisco, which is become the first city that do that. So what is your opinion on this, whereby which one is good, you know, in terms of public safety? Thank you very much.
Thank you, Encik Zabri. So I would like to offer. Okay.
Thanks. Okay, honestly, I just visited Beijing, I think early this year. I mean May, middle of this year. Now, I'm very fascinated with the number of cameras. I mean, in Beijing. Anyway, you see, any spot I think is about 5 to 10 camera pointing at various sites, and in any road in Beijing, even the outskirts, they are every let's say 500 is about 500 meters. There are cameras pointing. I think from again, this is actually a double-edged sword to us, right? Whether it's actually balanced between the public safety versus the privacy. In China, there is no privacy issue, so it's all about public safety. So you want to make sure that the city is safe, and pretty much I feel that, you know, when you go anywhere, since the camera is there, you see as long as you are not a bad guy, you see that you are under safe control. Also, I just came back from France. I talked to my supervisor there and visited his chalet. We talked about this issue as well. He pretty much agreed that as long as you go out to the public, you forget about your privacy, because somebody, not just a machine, but somebody know that you are there. Just that they don't record you. So you can't say when you go out to the public space, but you want to protect your privacy. If you want to protect your privacy, you hide in your house. That is actually the sentiment. Even the German and French. That is actually so. I don't have the answer to that, but this is just the sentiment. Yeah.
All right. So even if you go and see the trend of the CCTV, DDoS attack, botnet distributions, we will see that the number of the cases are increasing as well through the CCTV. So I think CCTV is should be something helpful for the smart city. But however, of course, there should be some threshold value saying that a number of amount of number that is sufficient for that city, which is appropriate enough to support for evidence in law cases later. However, if they use for extensive information, so it will be overloaded of extra informations, which I think they might be a bit deviate of for the privacy of each of the individual. That's my opinion. So that's why, in fact, in Islam also, we don't do something extreme, right? We do something which is just a moderate. So as well as the applications, the tools that you use, it should be at optimal level, yeah, which is current. We could say is sufficiently enough to protect the human from. Or is sufficient enough to get an evidence law to dictate any criminal offence happen in that area. But if you have more information, it might give you a lot of details about your privacy as well. However, with this, rapidly used CCTV technology, Malaysia should also foresee about policies. Okay, I think the lack of Malaysia is about policy to protect the people as well as the privacy. Some of the data sharing information is vastly enough to be shared by the others. Maybe I can point out one of the issues, like the person Kim Jong-un died at the airport, right? So the China knows faster who's the killer. Who's the intention doing that? And it happens that probably the CCTV belongs to their company. So therefore, I think CCTV should be protected. Of course, it has to be secured in somehow about the stenography, second analysis, everything to, or maybe you want to be blockchain, so that it will support you at a minimum level to secure the public safety. But if too extensive usage, I may find that it may be give you a bit of deviate of data privacy to the other people. Okay.
So maybe I can add something, okay, to the question, to the answer. So in our experience, actually, that we once have the opportunity to talk to the United Kingdom's Home Office, so and we asked them about how they implement, a massive, face detection and recognition in the subway line. So how they implement the system. So what they told us is that the one interesting experiment that they did. So what they did is that they employ 30 orang pelakon tambahan. Okay, alright, 30 orang pelakon tambahan. So what they did, they recorded the 9 position of face, for each of these actors. So then what they asked these actors to just walk to any subway in the London subway, just walk. So they have no idea why the government asked them to do that. They are being paid to do that. Record their face and just walk in the subway. So what they did is that they put on several cameras, with different qualities in those subways. So they collected videos of the people moving in out from the subway. So from that video, actually they detected only those 30 people. Let's say the wanted list. These 30 people are the wanted list. Among the millions of people who are using this the service every day, they only want to detect these 30 30 faces. So it's quite scary to see. They can detect each one of them. And they told us also, the best algorithm so far when it comes to detect face in the public so far at that time, that is like 5 years ago, the NEC, face recognition. Okay, so that was like 5 years ago. But we actually got the ideas, okay, of using that 9 position of face in order to do the face recognition and also for face detection. So it's a very good model. So when it comes to the privacy, I don't think that, you know, yes, our face will be used for detection, you know, but I say that when it comes to implementation wise, it is very economical, you know, to detect and recognize and not to classify only those 30 people, you know, instead of 1 million of us. So that's mean, you know, it can be a criminal, terrorist, you know, and the people that, you know, prove to be very harmful for the population. So that's it. Thank you.
Thank you to all panelists for their insightful sharing. Now, we would like to invite Yang Bersahaja as Dr. Aswami Fadila bin Muhammad Arifin for a plaque giving ceremony and a photo session. To our first panelist, Professor Dr. Raveendran Paramesran from University of Malaya. Thank you, Professor Dr. Raveendran Paramesran. To our second panelist, Professor Dr. Siti Norul Huda from the National University of Malaysia. Thank you, Professor Dr. Siti Norul Huda. And to our third panelist, Dr. Yong, Director of Recorgine Technology. Thank you, Dr. Yong. And not to forget to our moderator, Mr. Nazri Ahmad Zamani. All panelists, please stand for a photo session with Yang Bersahaja as Dr. Aswami Fadila bin Muhammad Arifin. Please give a round of applause for our panelists. Thank you again.